we start working on problems from web work on section 1.5. Problem 1. Question is it possible for limit x approaching 2 of fx be 5 and yet f at 2, the value at 2, be 3? Okay. Well, here is an example. At 2, the value of my function is 3. F at 2 is 3. But look at the limits. When x approaches 2 from the left, the values of f go up and down and they approach 5 from the left. As x approaches 2 from the right, the values of f from the right go up and down and approach 5. In other words, the limit x approaching 2 of fx is 5 and f at 2 is 3. So yes, both of these is possible. So they want us to type in y for yes, n for no. It is a yes. Okay, next problem. Is it possible for limit x approaching 1 of fx to exist when limit x approaching 1 from the left of fx is 3 and limit x approaching 1 from the right of fx is 7? Well, answer is no. If the left hand limit is different from the right hand limit, limit does not exist. Okay, here is a picture of what they are saying. Okay, x approaching 1 from the left, limit is 3. S approaching 1 from the left, the limit is 3. X approaching 1 from the right, the limit is 7. Okay, notice how they don't match. So limit does not exist. Next problem. Okay, which of the following is the meaning of the sentence limit x approaching 3 fx is infinity? So here is 3. From the left, you want to go to infinity. From the right, you want to go to infinity at 3. Okay, so that's what you want. So x approaches 3 from the left. Fx is getting arbitrarily large. Yes. From the right alone, from the left alone, well, it should be arbitrarily large from both sides. That's what it means for limit x approaching 3 fx to be infinity. Okay, x approaches 3 from either side, fx is getting arbitrarily large, and as x approaches 3 from either side, who knows where fx is going? No, that's not right. A and B are partially correct. These are one-sided limits, but you need both sides to go to infinity to say limit x approaching 3. Okay, without a specification of right or left. Answer is 3. C rather. Yeah. So, all right. Next one. Okay. Now, here is a function. For the function f whose graph is given, state the value of the quantity. All right, let's see. So somewhere here is 0, right? X approaching 0 of fx. To 0, from the left, you're approaching 3. From the right, you're approaching 3. Okay, so I'm just looking for limit. I'm not looking for value. Value at 0 is also 3, but that's irrelevant. Limit, you're looking at the branch to the left, branch to the right of your function. Okay, well, both the branches meet, this branch and this branch, they meet at 3. So answer is 3. What about 3? Add a minus above means your x is approaching 3 from the left. Here is 3. So I'm looking at the left branch around 3. So branch, I'm not looking at right branch, I'm not looking at value, I'm looking at the left branch. Left branch approaches 4. Limit from the left is 4. Limit x approaching 3 from the right. For 3, the right hand side branch approaches height 2. So limit x approaching 3, well, the two branches do not agree. So limit does not exist. What's the value at 3? At 3, value is this height, which is 3. All right. Next problem. Okay. For the function f whose graph is given, similar question. So let's look at this. Limit x approaching 1 from the left. So here is 1, you're approaching from the left. So I'm looking at the branch to the left. So here is 1, to the left is this branch. The height is approaching 2. So left hand limit is 2. Right hand limit. Okay. Right hand limit, the branch does whatever it does, but the limit approaches height 3. So what about limit x approaching 1? Well, the two limits do not agree. So it does not exist. What about 5? 1, 2, 3, 4, 5 here. So the left hand limit approaches 4. The right hand limit approaches 4. So the limit is 4. What about the value of f at 5? Well, there is no point for 5. In fact, there is a hole. There is no point anywhere for 5. So this does not exist. Okay. I'll stop this video. I'll continue next problem on the next video. Until then.